0.02 inches. Now, it looks like it's metric. Maybe I'd do 1 millimeter. Anyway, 30. So when I go to locate this hole, I can be assured that that is 29.98 to 30.02, right? Due to that tolerancing. Now, when I come to this part, the 40, what's the size of it going to be? It's going to be 39.98 to 40.02, right? It's got the same two tolerance. I know it's going to be 40 plus or minus 0.02. What's this guy going to be? 60 plus or minus 0.02. Each dimension has its own tolerance. If I need a high degree of accuracy, this is the way I'm dimensioning, right here, and it's because of tolerancing. Now, let's compare it with this one. So the first one here is 40. This would be either 39.98 or 40.02. Let's assume right here that it is 40.02. Okay? Now I come to this part, and let's assume it hits its upper limit too. It's going to be 50 plus or minus 0.02. Let's say it is 50.02. Well, what size is this one right here? It's 130 minus 90. This should be 40, right? Mm-hmm. Well, can they now do 40, 50, 40, and still stay at 130? Can't do it. They would be over, because this is really tolerancing stack up. Okay, so on this one, we know we're 40.02 right here. Okay. Well, when we get to this side right here, I can be up to 50.04, correct? If I'm measuring from this edge. So this one has that tolerance plus that tolerance. And the next one would have it again and again. And if you put 5 or 6 of these in a row, you can be significantly off if those are important. Now, when I say this, neither one's good or bad. Maybe what's important is the 50 compared to the 40 compared to the 40. I would use chain. If I need them to be accurate to an edge, I would use coordinate dimension. So keep in mind, those tolerances are what we call tolerancing stack up. Has a significant part to play when we pull a dimension style. Okay, because we can see that tolerance transferred from one measurement to the next, and then those two transferred to the next, to the next. You kind of get that?
You called it tolerance stack up or stack?
Yeah, tolerance stack up is what I usually call it. That just means I've got multiple dimensioning tolerances being applied to the same dimension. So there is a difference on how you do those.
Instead of putting the 130, we can continue the dimensioning and put 40 in the area.
No, that's the other thing I wanted to get to on this figure. So your thing was, why don't I just put a 40 here and tell me if I'm not reading you right? And I don't put that one.
Yeah.
Okay. This is impossible to build. They will not build this with that tolerance. Statistically, it's impossible. Because keep in mind, this will be 39.98, 39.99, 40, 40.01, 40.02. Okay. Well, if I do that and I get over 40.01 and I get over here, I cannot meet this tolerance. I can't meet it. So what you generally do, and this addresses it, Majed, you're on the right track, but it's dimensioned correctly. What we do is we take the least important part and we don't dimension it in chain dimensioning. So we just leave this area with no dimension. Because for some reason we're saying this is the least important part. We know you can't build this due to tolerancing stack up. Bury the air here. Okay, because the 130 is more important than the 40. Okay, does that kind of make sense? Because usually the overall is much more important than one of these legs. Okay, so what we're telling them is we want 40 plus or minus 0.02, 50 plus or minus 0.02, 130 plus or minus 0.02. We don't care what this is. It's going to fall out, right? So leave one leg undimensioned in there.
If
Put an
there's no
overall, and it will fall out.
tolerance. But if there's no tolerance, you do it.
No, that would be double dimensioning. I don't put all of them. I certainly don't put 40 and then 130, because that's an unnecessary dimension. That's double dimensioning. So yeah, this thing's dimensioned perfectly, the way it is. This will take care of that tolerancing stack up by leaving this leg undone. And that machinist isn't going to come into the room and throw it on your desk and say, you go build that. They see the problems you have. So leave one leg undimensioned. I think we did that yesterday when we were kind of looking at our figures. As we did just one leg and then we did an overall, we didn't do two legs up the side of number 1 and 2.
Do employers have a preference of what you do, or is it just,
No, they'll go either way on it.
okay?
They'll go either way on it. It depends on how accurate we need to be. So really, it's a function of what the part needs to do, on which method we use. Now, there are some other caveats. We've talked about the tolerancing technique, but let's go back to coordinate dimension. Coordinate dimensioning is pulling all dimensions from a fixed edge. It's also called datum dimensioning, same thing. Okay. Remember, datum is a theoretical perfect place or plane. This is datum dimensioning, it's also coordinate dimensioning, where they're pulling everything from a fixed edge. Not only is this more accurate than chain in certain instances, this works with cutting equipment. So many times we will use this dimension style if I'm working with some CNC piece of machinery. Okay. Do you guys remember when Jim was talking about the 3D printer and said, oh, the thing's got a 0 at this point and then it's going to go find the point and start building it? Okay, well, does that work with this? Same Cartesian grid. Many times we'll do this, we'll put our parts on 0, 0, and we can ship it right to the computer from ours. Nobody even has to run the machine. Okay, we just set it up in the morning and we're cutting all day and never get up and check it, other than to have somebody feed material into it. So a great dimensioning style if you are working with CNC equipment. We have a few places around here that have those. One of the neatest ones I've seen is Oakley Stone. That's kind of a cool little operation. They have a water cutter for rock. They use this method right here. Now, besides this one, we also have another technique with coordinate dimensioning that works really well. And if you go to figure 1712, you'll see start of it. It's called tabular dimensioning. We do this when we have repetitive features. Okay, so tabular dimensioning is pulling items off the drawing and putting those dimensional information in a table. It's almost always a coordinate dimension style. Okay, so here they've kept the location dimensions of these holes on the drawing. Notice the horizontal, what I said don't use with leaders. We do this with tabular dimensioning or coordinate dimensioning. Okay, we pull them straight. Now, this one's all coming from a fixed point or edge, so it's coordinate dimensioning. They've pulled the size out and put it in a table. Why would we do that? Many times we build things that are very similar and we just change the size of holes. Think of PC circuit boards. Think of flanges for pipes. Many of these items are the same. We just change the sizes. Maybe I got a 1/2-inch bolt in one situation, I got a 5/8 in another. Okay, so I've got to make the hole bigger. We use the same drawing for both. All we do is edit the table. We leave the drawing the same. Over here, they've gone one step further and pulled location and size out. This is really the process they use for circuit boards, right here. You'll have one circuit board, has a bunch of holes in it, and everything is pulled off and done on the side in a table. With tabular dimensioning, putting your dimensions in a table to aid in clearing the drawing up. Notice you can't switch the origin.
Yeah.
Like here it's given the origin here. You do need to define the origin if you're using tabular dimensioning. Didn't have to on this one because it's defined on the drawing with coordinates. Yes, Becky?
Why would you have the origin at A4?
Not sure, but you can. I'm not 100% sure. I haven't worked for Micron. I know they use this style, I've seen it. But as far as the purpose behind it, I'm not really positive. Does anybody out there know? Anybody come across something? I'm not sure, just other than the fact that we can move it.
Okay.
I'm guessing, and this is a total guess, this is how I'm mounting the thing somewhere. This is the important hole.
Oh.
Okay, so I would need to make that mount or made up perfectly, because remember, there's slop on everything else. But we're gonna call that one our dad, or our theoretical perfect one. All right, boy, we covered a lot there. Okay, let's do some leader stuff here real quick. Just make sure we clear some of this up. When we're doing leaders, let's go to page 828. So leaders, we already talked about, they point to an object line. You do have some instances that are different. Here they're doing a finished surface. So the leaders are pointing to these center lines here. And then they're calling out a finished surface. So when you're doing surface finishing, like sanding wood or putting a diamond knurl on it, the diamond knurl is that little kind of diamond looking thing that helps you grip stuff. What you do is you put a center line a little bit off of it. They're using actually the chain line from the alphabetical lines here, but for the most part nobody uses that. You'll use a center line and then just point to it. Now if you point to the surface, like this one does, the ANSI standard is you should switch that arrow. It should be a solid filled dot. That's the ANSI standard if you're pointing to a surface, not an OBJ line or an edge. Okay? So keep that in mind. If you're coming to a surface, telling them how to treat that surface or whatever the case might be, switch that thing to an 1/8" diameter circle. And it should be closed filled, it should be solid dot.
And your arrow has to touch a line, it doesn't touch a gap?
No, it should always, that arrow should always be on a line.
Okay.
Okay, always. Yeah, never off to the side of it. When you're doing leaders for cylinders, which is, for the mechanical world, this is the majority of your leaders, they should be radial. Okay, by radial, they should point towards the center. Okay, so in essence, that's what they're doing here. They've got the thing coming in, it's pointing to the outside object line, comes up, you got your shoulder, 45 degrees approximately. But this arrow right here, if you were to extend it, it should pass through the center. This thing shouldn't be sitting like that. Again, we're going to aid them in finding where the center is. As you folks now well know, when you're doing any arc or circle, what's the first thing you have to do? Find the center. When these folks are laying this stuff out on stuff to build it, what's the first thing they need to know? Where's the center? Okay, so we're going to do everything we can to help that out. So all your leader lines will be radial when dealing with circles or arcs. If I have an arc, okay, and maybe it's so small I don't even have this cross, doesn't matter, folks. At that point, I am still radial, where if I was to extend that, it would pass through the center, even if I don't show it. This isn't even on here. It's a real small one. I can't put it on there. I leave it off. Remember, I've told you that many times. Get so small you can't do the cross, leave it off. My leader line should still be radial, or point towards the center. How long have I been going? I've been going 45 minutes.
I got a question for you.
Sure, shoot.
When you're dimensioning a diameter, you always point to the outside,
Yes.
Yes.
and the radius, you come with the inside, and you go, see, you can go the outside or inside from the radius.
Yes.
Is there a preference for when you do
Yeah,
that?
we do have a preference. That's actually tomorrow's lecture.
Okay,
But
that's
let me just kind of point it out, since you're already there. On an outside, or a full circle diameter, it should be outside like this one.
Full circle, okay.
Full circle should be outside. Whenever you use a diameter, your arrow should be the outside. And then let me just point out this figure. We're gonna come back and look at it later, but go to figure 1734. We'll look at this again tomorrow when we do a detailed study. This is the way your radius should look. Okay, so on a radius, your arrow should always be on the inside of the curve. Hopefully the text is also on the inside. Sometimes these will get so small that I can't put it like this one, and then I revert back to a full circle and I pull it to the outside. But this is the preferred. It's inside the curve. Okay.
But it can be outside.
If it gets really small. Yeah, because you've seen, we do all those fillets and stuff, many of them are 16th and 8th. You aren't getting an arrowhead in that space. Then you would pull it to the outside. We'll talk more about that later, so worthwhile rabbit trail to get on.
Okay.
Let's take a break and come back, and I've got another 10 minutes of stuff to cover, and I also wanted to give you a chance to ask any questions you might have on the drawings that you're seeing. Let's take a quick break, and we'll pick back up in a minute.